Sequences. So I'm going to just do this very basically. There's a lot to be said with sequences and series, but you'll probably see that in geometry, I think. Maybe algebra too. So we're just going to go into the basics. There are two types of sequences. We have an arithmetic sequence. And then we have a geometric sequence. And instead of just telling you what these are, I'm going to show you an example of each, and then see if you can figure out what these two terms do. So an example of an arithmetic sequence, 2, 4, 6, 8, 10, 12. And then you usually see an ellipsis at the end, saying this would go on forever. Example of a geometric sequence. Okay, so take a minute to look at that, copy it down. What makes this sequence arithmetic? What would you guess? Mira?
You're just going forward 2 every time.
Yeah, we're always, what's the mathematical operation that we're doing? Adding 2, right? We're always adding 2 to get the next number in the sequence. What makes this sequence geometric? Andrea?
You're multiplying by 2.
I'm multiplying by 2. There's nothing special about the number 2, but if I'm adding the same number each time, I'm going to make an arithmetic sequence. That's the definition of an arithmetic sequence. Right? A series of numbers, a sequence of numbers that are always the same distance apart. They have a common addition between each number. Whereas a geometric sequence increases, sometimes we say geometrically, because each time we multiply by 2. And there's like fancy ways to write this stuff out. We're not going to get into that. I just want you guys to know the basics. Arithmetic sequence means adding, like the A. Geometric sequence, you have to remember, multiplying. So if I gave you a sequence of numbers, like 3, 17, 31, 45. Can you tell me, is that a sequence? Is this a sequence?
Oh, wait, is it? No, it's not. It is a... Oh, wait. 3 plus 14.
Yeah. It is a sequence. Is it arithmetic or geometric? Yeah. And the way we figure that out is we look at the first two numbers and we say, okay, if this is arithmetic, I'm adding 14 every time. If this is geometric, I'm multiplying by 17 thirds each time. Then I look at the second two numbers. 17 plus 14 is 31. 17 times 17 thirds is not 31. I have no idea what it is, but it's not 31. So it's not, we're not doing that to get from here to here. And then we do have to keep looking. We have to say, okay, now I'm pretty sure that I'm adding 14 each time. How about the next one? 31 plus 14 is 45. So this checks out. This is an arithmetic sequence formed by adding 14 to the previous number. All right. Questions about that? Yeah, Ben.
Are there any sequences where you divide or subtract?
Yeah. So if I were to, actually don't know a lot about that, but you know, you could imagine like if I said 10, 9, 8, 7, 6, you could continue that sequence, right? Eventually you'd get into negative numbers, right? Or if I said 1,000, 100, 10, 1, you could probably continue that one as well. Here I'm adding negative 1. Here I'm multiplying by 1/10. metric, this is arithmetic. Good question. Right. So if I have a sequence, say I had a sequence like this, 50, 150, 250. What is the next number in that sequence?
350.
350! Yep, that's it. Okay. I think that's probably good for today. Like I said, there is more to this. There's some sort of common sense stuff about this. If I had this original sequence that I talked about, this would be called the first term. Right? So what term would this be?
The fourth.
The fourth term? Yeah. Kind of makes sense, right?
So
These are sequences. Just so you know, series, we're not going to get into this today, but series are a totally different thing. Like when we use these words in common English, a sequence and a series, we both just think like, oh, a group of numbers that follow a pattern. But in math, like technically speaking, we have sequences and series, and they're two different categories of things. All right, I'm going to give you a problem to think about. Let's look at this thing. I want you to tell me what would be the 31st term in this sequence.
it would be 62.
So is there an easy way to figure this out?
Yeah. Multiply 31 by.
Yeah. Right? Here's my first term, it's 2. My second term is 4. My third term is 6. My fourth term is 8. My fifth term is 10. So my 31st term is just going to be 2 times 31, which is 62. Right? What about, I'm going to give you a different sequence. What about if I had this? Three, 5, 7, 9, 11. What would be the 11th term in this one?
22.
So my first term is 3.
But you're adding by 2.
I'm adding 2 each time.
But they're. Oh.
So let's think of it this way. If I call these numbers n, so n means if n is 1, that's the first term in my sequence. If n is 2, that's the second term in my sequence. What am I adding each time? I'm adding 2. So I know that I'm somehow, if I want to figure out the term, like which term I'm at, I have to multiply the term that I'm at, n, times the number that I'm adding each time, 2. Right? So this, we could call this our constant difference. Times the number of the term. Right, or the order of the term. But that's not going to work here because my first term is 3. 2 times 1 does not equal 3. 2 times 1, how would I make that 3? What would I have to add to make that 3? I'd have to add 1. So that gives me the first term. 2 times 1 plus 1 is 3. But does it give me the second one? 2 times 2 plus 1 is 5. I wonder if this works for every single term in the sequence. Let's try it with the 5th term. 2 times 5 would be 10, plus 1 is 11. It seems like it works. So if we figure out, right, we can figure out what to add. By looking at the first term, right? So if we take our constant difference, multiply that by the number of the term, n, the number that we add will be the same for every single term in that sequence. So we just look at the first term, we figure out how far it's off. 2n is 2, the first term is actually 3, and we just add that. And then we have a formula that can predict any number in the entire sequence. So the 11th term would be 2 times 11, which is 22, plus 1. So our 11th term would be 23. You could figure out the 7,523,000 term if you wanted to. Just multiply whatever I just said by 2 and add 1. Alright, let's try one more example of that. Alright, give me a formula to predict each term in this sequence. Am I adding 2 each time? I'm adding 10. So I know that I'm going to start with 10n.
Plus 1.
10 times 1 is 10. So according to this, my first term is 10. What is my first term actually? 51. How far is this off?
Okay, 50n plus 1.
No, I'm not going to change this. I have to figure out the difference between what this says my first term is and that is 41. So I need to add 41 in order to get it. So now if I say, okay, first term, 51, right? 10 times 1 is 10, plus 41 is 51. Second term, 10 times 2 is 20, plus 41 is 61. So I start here. I simply take this constant difference. What am I adding each time? And then I figure out how much I need to add or subtract. It could be subtracting to make that first term. Let's do one more example. I know we're running out. Okay, what am I adding each time? 7. How do I make? Yeah. How do I make the first term? Subtract 4 to get 3, and that's it.
Why?
7 because I'm adding 7 each time. That's why I get the 7. 7 minus 4 is 3. That's why I get the minus 4. All right.